Let's do an example of how to graph a rational inequality. Remember, the word rational means fraction with x in the numerator and denominator, or any variable in the numerator and denominator. So the first step would be we need to make sure that the inequality has 0 on the right side and everything else is on the left side. To do this, you may only use addition or subtraction and then combine using the process of finding common denominators. You cannot multiply or divide to eliminate things, and definitely don't cancel anything out that would cancel out. Okay, the second step in finding a rational inequality is to factor. So if we were to go and factor this rational inequality, the numerator becomes x minus 4, x plus 2 over x minus 5 and x plus 5. You're going to keep the sign the same, greater than or equal to 0. Step 3 will be to put critical values from the denominator on a number line using an open circle, and put critical values from the numerator on a number line following the sign of the inequality. So let's take a look at what that means. We've got here a number line, and I'm going to start with the denominator first. Recall that the denominator in any rational expression can never equal 0. So that means if this were an equation, x could never be 5 or negative 5. So let's put those values onto a number line. And those are going to follow, or those are going to have always open circles. I like to do circles on this because we don't know which direction the graph's going at, so parentheses you wouldn't know, so that's why I use open circles and closed circles. Alright, so the denominator will always be open. Then we are going to put the critical numbers, meaning where will equal 0 here. So in this case 4 and negative 2. We're going to put those values, 4 and negative 2, and they are going to follow our inequality sign. So our inequality says greater than or equal to, so because it is equal to, it will be a closed circle. Those are all of our critical values of an inequality. They are where the numerator would equal 0 and where the denominator equals 0. Alright, now that we've put our critical values on the number line and determined if they're open or closed circles, look and see how each of these points form specific regions. So we have the region here from negative infinity to 5, the region here between negative 5 and negative 2, the region between negative 2 and 4, and then the region between 4 and 5, and last, the region 5 to infinity. So what we're going to do with that is we are going to pick a value in between each region. So I'm going to pick here, I'm going to pick the value 10. In between in 4 and 5, I'll just pick 4.5. In between negative 2 and 0, I always get really happy if 0 is in my region because it's the easiest thing to test. Between negative 5 and negative 2, let's test negative 3. And from negative infinity to negative 5, let's go negative 10. You can pick any values. These are just values that I randomly picked. Well, not necessarily random. I picked the easiest ones I could think of. And so what we're going to do with these is we're going to plug them into the original equation. Now if your original equation has not 0 here, plug it into the first equation that you have solved where it's simplified version where you have 0 on the right side. So if I plug 10 into the original equation, I just want to know if the number is positive or negative. So I'm going to plug 10 into the top. 10 squared minus 2 times 10 minus 8 is going to be a positive number. 10 squared is 100 minus 25 is also positive. So here, a positive divided by a positive is positive. Okay. Then if I do 4.5, this one's going to be kind of hard. You might want to grab a calculator. 4.5 squared minus 2 times 4.5 minus 8 is a positive 3.25. And then 4.5 squared, that's in between 16 and 25, so it would be less than 25. So a number less than 25 minus 25 is going to be negative. See, I didn't even have to do any math on that one. I just need to know if my number is positive or negative. If we plug 0 in, we get 0, 0, negative 8, and then 0 squared minus 25 is negative. What's a negative divided by a negative is positive. Oops, I forgot to do this one. A positive divided by a negative is negative. If we plug negative 3 in, we get 9 plus 6, 15, minus 8, positive 7. If I plug negative 3 here, I get 9 minus 25, which is a negative. So in between here would be negative. And then plug negative 10 in. Negative 10 squared is 100. Because the number is so big, it doesn't matter what's happening with the rest of the stuff. That's going to be positive. And then the bottom, 100 minus 25 is also positive. So this number is going to be positive. Alright, the last thing we're going to do is we're going to check which intervals follow the inequality sign and then write that answer in interval notation. Alright, so we had positive, positive, negative, positive, negative, positive. That was what we ended up with our sign chart. Now, we are looking here at the inequality, and we have that it has to be greater than or equal to 0. Which one of these intervals, a positive interval or a negative interval, would be greater than 0? So obviously the positive interval is greater than 0. So then we have our graph become the positive intervals. So then as interval notation we get negative infinity to negative 5. We don't include 5, so that's a parenthesis. Then we have from negative 2 to 4. We can be equal those values, so it's a bracket. And then our last interval would be 5 to infinity. Not including 5 because it's open. And then there is our final solution to the rational inequality, would be the interval notation.